An object is launched horizontally with a velocity ux. It lands at some distance from where it started. We are interested in finding the horizontal velocity given the horizontal distance it covers and the vertical height from where it was launched. You can try this problem and pause this video here. We can solve this problem by applying a basic kinematic equation S equals ut plus 1/2 at square. We must note that S equals minus h. Why is that? Because the object falls a distance of h. Since it points downwards, the displacement has to be negative. Uy, the initial vertical velocity, is 0, and that's because the object is launched horizontally. The acceleration, on the other hand, is minus 9.81, because the acceleration vector points downwards and is a constant of having a value of 9.81 meters per second square. If we use these values and plug it into the equation above, we get another equation, minus h equals half gt square, which can be solved to yield t. Upon rearranging the equations, we end up with t being equal to 3.19 seconds. Since we have the time and we have the horizontal distance, we can use both of them in the equation. Distance traveled equals velocity times time. We can rearrange this equation as velocity equals distance over time. Now we can substitute the value of x and t into this equation. Upon solving this, we get a value of about 20.4 meters per second. And that solves this problem. If you found this video helpful, make sure to like and subscribe. I'll see you in the next one. Happy learning.